everybody, and welcome to COP345. The topic in this session is visibility into internet issues impacting your application performance. So, if you are a network engineer or an application developer responsible for running your internet-facing workload on AWS, you are in the right session. This is a 300-level session where we'll discuss how CloudWatch Internet Monitor offers visibility into internet issues impacting your application performance. My name is Richie, and I lead product management for internet monitoring at AWS. I'm delighted to be joined by Harvo Jones, Senior Principal Engineer, and Peter Wido, Network Architect at EA Sports. So here's what you can expect in the next 1 hour. I'll do a quick refresher on observability in CloudWatch before we start diving deep on internet monitoring. We'll then take a look into common customer challenges with internet monitoring today, and then I'll cover the value that you will get as a customer of Amazon CloudWatch Internet Monitor, followed by a demo. Harvo will then take you to the journey behind the scenes and explain how does it all work. Finally, Peter Wido will share EA Sports' journey with Internet Monitor, and together we'll review the new capabilities that we have introduced this year. We should have some time towards the end for Q&A, so keep your questions ready. I know this is a 300-level session, and many of you in this room are already experts in CloudWatch. But just to level set, I'll provide a quick refresher of observability in CloudWatch. So CloudWatch is the native observability platform in AWS with the primitives of logs, metrics, and traces that you can use to monitor your resources and applications on AWS. You can alarm on these, generate custom dashboards, and even publish events on which you can automate some actions. CloudWatch is built to handle high scale. It is cloud native. Multiple AWS services automatically publish telemetry data to CloudWatch without you needing to do anything. CloudWatch provides you with a single solution for both metrics and logs and helps you connect and correlate the two of them together. This is really useful when it comes to troubleshooting. CloudWatch has also built additional observability tools on top of primitives that allows you to correlate metrics, logs, and traces across your application to get specific insights. Service lens and X-ray allow you to correlate at the region or application level to identify issues with your infrastructure and quickly narrow down the root cause of the problem. In addition, other tools like Log Insights, Resource Manager allow you to quickly analyze your logs and metrics for resources so that you can get valuable insights. Lastly, CloudWatch also provides some end-user experience tools. Synthetics, Evidently, and real user monitoring are some examples. Now let me ask you, how many of you here have heard your end users complain, I have a degraded application performance. I don't know whom to blame. Is it application? Is it network in the middle? Or is it AWS? Give me a show of hands. Not everybody? So when we spoke to customers like you, we have often heard common themes of problems emerge. For example, how many times have you heard that your monitoring dashboard was showing you a normal situation, and at the same time, you received customer tickets who reported that your app is slow or unavailable to them? And how much time did it take to diagnose these issues? We have heard from customers like you that capturing and monitoring data about internet traffic before it ultimately reaches your infrastructure is either very difficult or very expensive. It is often very hard to predict a reliable end user experience. Well, we listened, and we are proud to announce Amazon CloudWatch Internet Monitor, a new feature in CloudWatch that gives you visibility into internet issues that impacts the performance and availability of your application. It allows you to reduce the time it takes to diagnose these internet issues from days to minutes. Using Amazon CloudWatch Internet Monitor, you can now learn about all the problems that arise on the internet that your end users are experiencing in different geographic locations and networks without you needing to write a single line of code. Internet Monitor also provides you the capability to improve your end user experience by recommending you to use different services or routing the traffic to your workload through a different AWS region. So Internet Monitor can help you as an application developer to rule out internet as the cause of issue within minutes. Thus, it helps you avoid spending that unnecessary time to debug the application. You can now maintain high quality of service for your internet-facing application. It also helps you as DevOps network operators. You can monitor your network continuously so you can better understand the performance of your application, and you can make decisions to route user traffic to alternate endpoints as needed. It's now time to take a deep dive look into the capabilities of Amazon CloudWatch Internet Monitor.
Issues impact the end users of your application. You want to be notified fast. And because they connect to your app through multiple internet providers, it's difficult to diagnose the root cause of the issue. With Amazon CloudWatch Internet Monitor, you can quickly identify the cause of performance issues, saving valuable response time. Using Amazon CloudWatch Internet Monitor, learn about problems that arise on the internet that your end users are experiencing in different geographic locations and networks without writing a single line of code. It also provides insights and recommendations to help improve your end user's experience by comparing your current performance with estimated performance from other AWS services. And it also suggests regions for placing your workloads to get the best internet performance based on your user traffic profiles. You can see a global view of traffic patterns and health events, and easily drill down into information about past events at different geographic granularities. To support your integrations with other tools, Internet Monitor provides logs on the geographies and networks specific to your application in Amazon CloudWatch Logs. It can also deliver internet health notifications through Amazon Event Bridge. If the problem is on the AWS network, notifications on the AWS Health Dashboard let you know what steps AWS is taking to mitigate the issue. So whether you're a small-scale startup or an enterprise-sized business, Amazon CloudWatch Internet Monitor helps you proactively monitor the performance and availability of your application.
All right. Are you excited now to see it all in action? Louder. All right. Let's now jump to the CloudWatch console. So as you can see, I'm on the application monitoring section. You can see Internet Monitor available in preview. So in order to get started, you need to create monitor. Creating a monitor is super simple, just a couple of steps. So let's do it together. In order to get started, I click on Create Monitor and specify the name of monitor. Next step is to choose what you want to monitor. So in the preview, you can monitor your VPC, you can monitor CloudFront distribution, and you can monitor your workspace directory. So for this demo, let's say I pick up one of these VPCs that I want to monitor. You can choose one or more VPCs. You can add a mix of CloudFront distributions to your monitor, depending on your need. So I go ahead, click Add, click Next, just verify everything you entered is correct, and hit Create Monitor. Easy? Easy? Awesome. So I'm now going to use one of my existing monitors because it takes up to 10 minutes for Internet Monitor to determine your internet-facing traffic and start publishing measurements for you. So let's take one of these existing monitors. So this is the look and feel of the product. You now land into the overview page. You see health scores. So there's availability score, there's performance score. Now let's choose up to 3 weeks back, hit apply. I'm going to zoom in a little bit for you. Let's zoom it a little more. All right. So as you see here, around 15th November, I do see a drop in my performance score. So whenever there is a drop in your availability or performance score below 95%, that's when we issue a health event. And you're notified of these health events with this vertical red bar. I'm scrolling down and showing you the view of the internet map. So we help you prioritize what are those top areas that needs your attention where something is broken. Let me hover my mouse on one of these impacted locations. So one of these locations, for example, you can see a quick view of what is the impact of this event on your traffic. Section at the bottom gives you a list of all the health events with the details on the client location, the client traffic, the service location, the impact on your traffic, and the type of impact, whether it's an internet availability issue or it's an internet performance issue. Now you can take several actions on this. You can download these events, either as CSV or JSON, or you can go deep dive into this by clicking on View Historic Events. So let's go deep dive. Let's go to Historical Explorer and understand more about these outages. So at the top, you have the capability to filter by AWS location, by city, network provider, and so on. So let's choose city is Ashburn. Now you can see details on performance score, availability score, bytes transferred, round trip time for 50, 90, and 95 percentile. Section in the bottom gives you a list of all the events. You can go and take actions to download this event data as CSV or JSON. Now, I got notified there's a problem. There's a health event. Where is this event going on? And what's the impact on my traffic? The next question is, what do I do with this data? What's next? So Traffic Insights here gives you some more visibility into your internet traffic. The view at the top gives you a breakdown on your overall traffic with the traffic in, traffic out, average time to first byte, availability score, performance score. You have the capability to view this top 10 client locations at various granularities, city, subdivision, country, metro, and you can sort them on highest to lowest or lowest to highest. So you'll see here that Ashburn has the highest traffic by city. As you scroll down further, there is some interesting traffic optimization suggestion for you. So you see a list of the client locations with the network, and you see the information on the current time to first byte. Along with it, you also see how you can improve your end user experience by either using a different service, so you can choose include EC2, include CrowdFront, or by routing your traffic through a different region. So this information over here can help you in making those decisions to make those architectural improvements to make the experience of your end users better. Now, there's more interesting stuff. So you can come to CloudWatch log groups, and let's say I do a filter by city. So this is the diagnostic log stream. I'm going to click on one of these logs. There's a lot of powerful information here for custom integration. You can see the client location, details on the latitude, longitude, country, subdivision, metro. And then you can also understand about the availability score, the performance score, the round trip time with different percentiles, and more insights on what would be your time to first byte with the service you're using and the service that you could potentially use to improve your end user experience. Further, you can come to CloudWatch matrix. So let's do a filter with Internet Monitor here. So once you do a filter with Internet Monitor, you can look at different measurement sources with the monitor and the metric name. Just like you do with any CloudWatch metric, you can create alarms here. Internet Monitor also publishes these health events in the event bridge. So you can do integration with your Slack, with your pager, or any other ticketing or monitoring system that you may have. Now that we have understood how does the product work, it's time to understand how does it all work behind the scene. I'll now invite Harvo on the stage to take us through this journey.
So yeah, once again, my name is Harvo. I've been with AWS as an engineer since 2011, and I'd like to take you through some of the thinking that has gone into building CloudWatch Internet Monitor, as well as share some of the challenges the team has faced and some of the techniques we've used to navigate those challenges. Hopefully, some of this will raise appreciation for the service, but also there might be some parts of this that might be useful takeaways that you can apply in your own space as you're building applications on AWS. And I'm also sharing this because it's kind of fun, right? It's kind of fun to peek under the hood and see how stuff is built. So in internet monitoring at AWS, it actually begins a lot earlier than when we started building this product. So the very first line of code written for Internet Monitor was written about August of 2021. So fairly recently. But if we extend the time horizon back a few years, within edge networking services, I've been with edge networking services my entire time at AWS. And in 2008, we launched Amazon CloudFront. So this is our HTTP content delivery network, which caches content at the edge for an accelerated experience. And some of the learnings that went into building and operating that service, routing clients to the right edge location, allowed us to launch Amazon Route 53, our authoritative DNS service in 2010. And building upon those learnings even further, we were able to build Global Accelerator in 2018. The teams within this organization along the way have also built a web application firewall for HTTP security, AWS Shield for protections at the IP and UDP TCP layers. And there are a few common threads across these services. Not only do you see these services focused on availability and performance as well as security, but every one of these also involve internet delivery. And so the time spent building these services and operating these services allowed these team members to build a lot of experience in running services in a highly available manner that are facing the internet. And we couldn't have done so if we didn't already have some monitoring that we were using behind the scenes. We have operators that maintain the availability of these services for our customers. And our operators have always needed visibility into the health of the internet. And over time, we've enhanced those monitoring capabilities that we internally have relied on. Not only have we enhanced those monitoring capabilities, we've also built automated traffic engineering so that we have systems that look at those monitoring results and place traffic on the right path to reach its intended destination. And all of these automated tools are managed by a team of operators to continue to maintain the health and availability of these large-scale services that we've been running for years. So what you see here today with CloudWatch Internet Monitor, it's actually the pinnacle. It's the pinnacle of the experience and the learnings of building and operating these services and running internet monitoring. The marriage of both of those together, all those learnings have allowed us to build this product for you. What we've also done is taken this offering and we've now brought it into the family of the suite of capabilities within CloudWatch around application performance monitoring. So of course you have metrics and logs with CloudWatch itself. You have application tracing with X-ray. You have canaries with synthetics, and a nice dashboard with service lens, and client-side visibility with real user monitoring. And finally, we now are able to add internet monitoring to the mix. So now we can probably talk a bit about the challenge of scale. When it comes to thinking about how to monitor the internet, you might start thinking about, okay, I need to get my head around what do I need to monitor toward, what do I need to monitor from, get your head around that scale. But not only that, you would also want to get your head around how can I present these results in a manner that's understandable and digestible to my customers. So starting with scale, if we're thinking about, starting with where we're monitoring from, I should say. AWS infrastructure, we have 96 availability zones spread across 30 AWS regions from which we're running 200 services. Now, if we really want to get our head around where we're monitoring from, our mind's eye has to peruse over to the global AWS network as well. Those edge networking services that I mentioned, CloudFront and Route 53, Global Accelerator, those are all running from these 400 edge locations that we have spread around the world in 90 cities. And in these locations, we have thousands of internet peering interconnects with telecom providers. And we built out hundreds of terabits per second of capacity. The idea of scale doesn't stop there, though. What are we actually monitoring toward? It's the internet, right? There are 4.9 billion internet-connected people on Earth today. And they're interacting with an internet that's comprised of 1 million routes, advertised by 74,000 autonomous system networks. And they're all advertising routes into the internet to deliver connectivity to roughly 167,000 towns and cities across the globe. So it might feel kind of daunting. How am I going to build something to monitor all this stuff? And it doesn't actually stop there. Those are just the endpoints that you're monitoring to and from. What about the measurements you actually take? Each time we decide to take on a new measurement, are we multiplying the effort that it's going to take to build this, as well as to frame it in a way that's understandable and digestible to our customers? So as is often the case when you're faced with something that seems really complex, a really good approach is to try to break it down into simpler chunks that you can get your head around. So what we started with Internet Monitor, the product that we're offering today, is we're starting with 2 measurements: availability and round trip time. So availability is fairly simplistic. It's the ratio of probes that have succeeded divided by total number of probes attempted. Round trip time is our proxy for performance. And the thinking is it's a reasonable proxy for performance for a large number of workloads as a first step. The idea being, if there are multiple routers along a path and one of those routers begins to highly utilize one of its queues, you have queuing going on, so packets going from one point or back to the other, their latency may increase. And so your end users might see a rise in first byte latency. If those queues become saturated, you see packets being dropped. Your end users might see a rise in last byte latency, which is a reduction in throughput. So a reasonable proxy for performance in many cases. And then on either end, we're measuring from our AWS regions and our edge locations, and toward what we've reduced to what we're focusing on as cities and autonomous system pairs. And then, of course, we aggregate that up for you into larger granularities. So what we end up with is a really high amount of data that we're, tons of measurements we're taking. In a given day, we're probably processing multiple trillions of measurements in a given day. When we zoom into just a single time window, say a 5-minute time window, that's a few billion measurements in a given time window. And then we try to highly aggregate that down to a few tens of millions of measurements. So The problem, though, is if we took that large volume of data and presented it to you, our customers, it would probably be overwhelming. There's no way a person can get their head around that. So what we then do is we look at your applications on AWS. We look at your virtual private cloud. We look at your CloudFront distributions and your workspace directories. We see who on the internet you're talking to. We take our large volume of data, we try to reduce it down to just the bits that we think are going to be interesting to you. And then when we have just those bits, then we apply our analysis and overlay it with a veneer of user interface, and that's the product that you're seeing. That's CloudWatch Internet Monitor. This journey has involved listening to our customers, and the feedback from these customers has helped us frame some of the important aspects that we've built in. So there's that personalized view I mentioned, taking our highly voluminous data set and try to reduce that down to the bits on the internet that you might be interested in. We've also freed you from the friction of having to modify your own applications to use this product. There's zero code required to integrate with it. You don't have the cost of turning on VPC flow logs. And if I touch back on that personalized view once again, even if we've reduced down the number of measurements to hundreds or thousands that are interesting to you, no person is able to look at a graph with hundreds of lines and make sense of it. So we actually go further. We take all those measurements and we apply some math to figure out the overall score that we think your end users are experiencing. So we reduce all those hundreds or thousands of lines down to just 2 lines. 2 lines that a person can get their head around. Here's your performance score from 0 to 100. Here's your availability score from 0 to 100. And if we talk about some of the customers that have helped us to shape this product, we can think of the top-selling games of EA Sports, or the payment processing of Stripe, or the IT business solutions of Tech Mahindra, or the ad delivery network of Smato. Every single one of those businesses, what they have in common is they rely on internet delivery. And it's been very useful to receive their feedback to help shape this product. So maybe I can share a little bit about what has gone into getting this right. I always get dry when I'm speaking. Okay, let's share a little bit about what has gone into getting this right. I say a lot that working with CloudWatch Internet Monitor, working with this team, has involved solving some really, really simple problems, but has also simultaneously involved solving some of the toughest problems that I've seen at AWS. And it's kind of weird to see both of those in the same camp. Sharing some examples, let's think about if you wanted to build a control plane. So a control plane, perhaps some API endpoint that you would like your customers to interact with, to sign up for your service, to configure their preferences. How might you do that on AWS? AWS actually makes it really simplistic to build up control plane quickly. As an example, you can stand up API gateway, use Lambda for serverless compute to handle your API method invocations, maybe persist some state in DynamoDB. What about a data plane? So the data plane for this product, what we're doing is we're vending into your account CloudWatch metrics. We're vending into your account CloudWatch log records, and we're also producing health events. So roughly 3 things that this data plane is doing. How might one do that? Here's an example. Perhaps you have content coming in from S3, which you're streaming to some Fargate workers, which are processing, aggregating, making some decisions, and then vending these results to your customers' accounts. This kind of data plane is a lot different than a data plane of those other edge services that I spoke about. CloudFront and Global Accelerator, those ones have technically complex data planes where you have to spend really lots of engineering time to get it right. But once you do get it right, it's kind of clear that you've gotten it right. A packet comes in one end, it goes out the other end, it's formatted in the proper way, it's right. This data plane is different in that we're vending information and our opinion on that information. How do you know when you've gotten that right? It's very subjective, isn't it? We're vending the conclusions that we're drawing. And so not only are we taking all this information, we're annotating and aggregating and filtering, we're also trying to look through this information to spot anomalies, what in our judgment look like anomalies. And then trying to use those anomalies to build up an overall score that we think is meaningful to you, to the end users of your application. But the thing is, how do we actually choose what makes an anomaly? You have measurements, time series data. You have an aberrant measurement, right? How far above the mean, how many standard deviations above the mean should we choose to say, hey, that looks like an anomaly? And even if we do identify it as an anomaly, how much impact to your end user's experience should we determine that has caused? Wading through these kinds of challenges is why a ton of folks that work with me, they've heard me say recently a lot, many times, that one of my new favorite job families, one of my new favorite roles of folks to work with at AWS are our research scientists and our applied scientists. These folks have a superpower to look at large volumes of data and help us make sense of it, and to work through proving whether this is right or wrong. I love working with folks that have that ability, and they've been teaching me all along the way to help me have the right language to use to express what we're trying to optimize for. An example would be the ideas of precision and recall. So imagine that there are actual events, health events on the internet, problems that occur. And then there are also the predictions of health events that our system is coming up with by doing its data analysis, right? And the result of those predictions are delivered to you via this product as health events that we're saying. So when these two are aligned, that's great. That means we've done almost a perfect job. But more than likely, there are trade-offs to make. If they're unaligned, you might have this out-of-focus view at the optometrist's office where a Venn diagram you can point to portions of overlap and say, well, this portion are true positives. That's where we've identified events that are actually occurring. If we're producing health events for things that didn't actually occur, false positives, right? If there are real problems that we didn't produce a health event for, false negatives. And of course, the things that are true negatives. And so the idea of precision is, when you speak, how often are you accurate? So that would be the true positives divided by the surface area of that dashed circle. And the idea of recall would be, when you speak, how much do you cover what should have been said? So that would be your true positives divided by the solid circle. And now that we have that language, we can understand some of the trade-offs that we can go after. What if we spent a ton of engineering effort to drive down those false negatives? That solid circle could get smaller and smaller and smaller, right? And the idea there is we're now no longer delivering false alarms. That's one angle we can optimize for. When I see this picture, I kind of think that's what I want out of my doctor's office, right? I don't want my doctor to miss a diagnosis because that could be life-threatening. You can also optimize in the other direction. What if we spent a lot of engineering effort to optimize away those false positives? Maybe that dash circle gets smaller and smaller and smaller. So in this case, we're now no longer giving false alerts. So you can trust what we're saying. And yeah, there are analogies for what this might represent. Sometimes I look at this and I think of maybe the criminal justice system. We don't want to falsely deprive someone of liberty, for example. But this idea of trade-offs from the analysis of all the data available to us and what we've built into the product applies to other areas as well. What about the precision, the geographic precision of where your clients reside when we give you visibility into the performance and availability? We could go down to city, but then there's also a chance that if we're looking at city level, there's not as high a density of measurements. A lower density of measurements can perhaps lead to false alarms, a less stable metric, meaning we lack statistical significance. And we can adjust for that by increasing our granularity, going all the way up to country. We have a large volume of measurements, a really stable trend line. But then, of course, if we did that, it might not be as usable for you as customers because you only get this really broad view. So there are trade-offs we've been making all along the way to build this product. Similar trade-offs in terms of the aggregation window that we're offering. You can go for high fidelity with a really nice, precise window, or higher stability with going for a wider window. Also trade-offs between fidelity and cost, right? One example with a really high probe count, increasing cost, that would increase cost in terms of increased data transfer, increased CPU compute, increased storage. So all kinds of trade-offs we can make. But yeah, I think I've spoken enough. Right now, what I would like to do is bring up someone who I'm thankful to have had the chance to work with. Our team has worked with for the past year to gather feedback to help shape this product. Here is Peter Vito, network architect with EA Sports.
Thanks very much, Harvo. So earlier on, Rishi asked if people, your customers, ever complained about your applications and what's to blame. Let's all be honest. We're all thinking the same thing. We're blaming the network, unconditionally, always. So just out of curiosity, how many network guys are in the room? All right, we'll take that as a victory. That's fine. So I'm one of those rare network guys that has accepted the fact that when an application has slowness or performance issues, it might be the network. I'm willing to go that far. But to set up the roadmap of how we partnered with Amazon, I'll just set up a little introduction into a typical experience that our FIFA players would have for connecting. So in typical fashion, you would have people like a blue and green shown on the screen connect into an EA region that's amicable for a good playing experience in their particular part of the world. Now, this is all based on some network SLAs, some metrics, and it usually works out to be geographically related. Not always, but most of the time. And that provides them a really good level of playing experience. So they connect up through their local ISPs, also shown in blue and green, and the session starts, their match begins in red. Everything is great, they're connected. However, when the match starts, we're able to do a lot of great telemetry gathering from the actual orange area where the game servers are, and be able to extract and be able to analyze the performance of that session. We're always trying to ensure our gamers have a great experience. However, even with all the great telemetry monitoring analytics in place, things can happen unexpectedly where we don't have that visibility to see why something is happening. When we have great telemetry out of the orange zone, everything's fantastic. We can tell that from the blue and the green players that it's not so great. We can tell that their playing experience is starting to degrade or suddenly shifts, yet our data shows that it is fine. So we've got these situations where we just don't know. And part of that reason is really, not to shift any responsibilities, but it's sometimes very difficult when you can't jump onto people's systems and do some tests to say, hey, what's going on? We're limited and restricted due to security, which is rightfully so. But the short of it is, we do have that circle of orange right there where that's essentially our view of the internet. We can only have that perspective because we can't see beyond that of what is actually going on. It's always a matter of perspective. The good news is, with the Internet Monitor from Amazon, that shifts now to the bigger red circle, simply because our perspective is now shifted from inside our VPC sampling to outside the VPC on the peering edge. We're now able to see that traffic. where it's coming from, its performance, index it, and be able to make better decisions with it. So focusing briefly here on the orange section first. So we have, again, we get application performance that we can collect from the actual players in a limited fashion, just to give us an indication of how good is the experience. We have great operational alarms from everything from infrastructure to network to host partners, et cetera, that helps us verify that resources, consumption rates, et cetera, are in the green. We have our game stack, which we have a fantastic level of telemetry letting us know if there are any issues. Those are all predictable. We can handle those. We know if something is going wrong, and we can react to it. The part that's missing is the perspective of the internet. If things are going great and our customers are having a great time, no one's going to complain. But when we think everything's running fine, but the customers are not, they're not happy, and we don't understand the perspective of what's going on the internet to help us understand how to react. With Amazon Internet Monitor, that gap is filled. We can now see what is occurring, which ISPs, what shifted, where did the latency start, the AS path to the ISP from the customer. So how EA is going to benefit from this is simply being able to make better decisions with this data. So operationally, we need to understand the traffic. We need to understand how does the path change. When the path changes, how does that affect the game? When there is latency in certain parts of the internet, does that affect the game as well? Sometimes yes, sometimes no. And building on that, using that to evaluate application performance on the internet. There are things that you're going to see that may not impact the game. What you're going to need to do is learn from that to learn what to react to and what not to react to. Because there's a lot of stuff that happens on the internet. As Harvo mentioned, there are over 1 million routes, 50,000 changes a day that are occurring on the internet. Sometimes things will impact you, sometimes they won't. And then lastly, reducing the mean time to detect. Now this one's a really interesting one for us because to detect something is great, but you also need to identify it. Because what are you going to do if you just detect? Like, I'm sure the fire department is going to be really interested in you calling that there's a house on fire, but when they ask you where is it and you don't know, well, that's interesting, but did you really solve anything? So that one's a really interesting one for us because now we're not just detecting, we're identifying. Sorry, went a little bit too far. And with that, I'll hand it back to Rishi.
Well, thank you, Peter, for walking us through that story and all the great insights. So, excited about Internet Monitor? Yeah. I didn't hear it. Excited? Yeah. Well, what are you waiting for? Go spin up your Internet Monitor and elevate the experience of your end users. If you're interested in learning more, here are some additional resources. We have Amazon CloudWatch Internet Monitor blog, What's New post, and link to the user guide. We also have a follow-up session on this Thursday, Net 213, so you can further learn about how you can improve the experience of your end users through Internet Monitor.